Hello guys, good morning everyone. Welcome to another episode of Xa Talk Show. We are going to code Advent of Code this year. So today, Advent of Code 2024, problem 1. Okay, let's have some eggnog, 14% alcohol something. So this is gonna be eggnog coding. And I'm coding in Wolfram language. Let's see how it goes. I heard the day one problem is not too hard. Okay, that's not too much. Fantastic, amazing advent of code. I hope you guys had a good holiday. I mean, the Thanksgiving. And here's me. My keyboards, Glove 80, fantastic. You should go buy it or give it to your friend, Glove 80. This is Ultimate Hacking Keyboard, also fantastic. I have reviews on my website. And there is the Sval board. Sorry, I haven't got to it yet, so I'll get on to it. So the event code, let's do it today. So let's see. So Emacs ready, Wolfram language ready, and if you have not already joined Xali Discord, you can find the invitation link on xali.info. Apparently, we have 3 people who are doing advent of code. We are doing it. So one is C++, one is something, Golang. Okay, let's begin. Let's see. If you are here, say hi. If you are not here, skip around. Play at 1.5 speed. So we got this X. I solved it already. It was pretty easy. Okay, let's see. Yeah, I heard it is easy. Okay, so this needs to be moved here, here, here. Okay, the big one. The chief historian is always present for the big Christmas slide launch, but nobody has seen him in months. Last anyone heard, he was visiting locations that are historically significant to the North Pole. So you got a chief historian. A group of senior historians has asked you to accompany them as they check the places they think he was most likely to visit. As each location is checked, they will mark it on their list with a star. Okay, mark it on a list with a star. They figure the chief historian must be in one of the first 50 places they'll look. So in order to save Christmas, you need to help them get 50 stars on their list before Santa takes off on December 25th. Collect stars by solving puzzles. 2 puzzles will be made available on each day in the Advent calendar. The second puzzle is unlocked when you complete the first. Each puzzle grants 1 star. Good luck. Okay, that's not even a problem. That's just introduction to Advent of Code. So you haven't even left yet, and the group of elvish senior historians has already hit a problem. Their list of locations to check is currently empty. Okay, eventually someone decides that the best place to check first would be the chief historian's office. Okay, upon pouring into the office, everyone confirms that the chief historian is indeed nowhere to be found. Instead, the elves discover an assortment of notes and lists of historically significant locations. This seems to be the planning the chief historian was doing before he left. Okay, so there is some assortment of notes, okay, and list of locations, okay. So perhaps these notes can be used to determine which location to search throughout the chief's office. the historically significant locations are listed not by name, but by a unique number called the location ID. To make sure they don't miss anything, the historians split into two groups, each searching the office and trying to create their own complete list of location IDs. Okay, so you're gonna be working with location IDs. There's just one problem. By holding the two lists up side by side, your puzzle input, it quickly became clear that the lists aren't very similar. Maybe you can help the historians reconcile their lists. Okay, so you got two columns of numbers. Each number is supposed to be a location ID. Okay, so maybe the list, so can you see it? Yes. So maybe the lists are only off by a small amount. To find out, pair up the numbers and measure how far apart they are. So you check the difference. Pair up the smallest number in the left list with the smallest number in the right list. Okay, then the second smallest left number with the second smallest right number, and so on. So essentially you order them first, then you pair. Then you compute the difference in each pair. Within each pair, figure out how far apart the two numbers are. You'll need to add up all of those distances. Okay, the difference, they call it distance. For example, if you pair up a 3 from the left list with a 7 from the right list, okay, let's see, 3 on the left, so there are 3 3s. And what? There's no 7 on the right. What? With a 7 from the right list, the distance apart is 4. Okay. If you pair up 9 with 3, the distance apart is 6. Okay. So in the example listed above, the pairs and distance would be as follows. The smallest number in the left list is 1. Check. And the smallest number in the right is 3. Check. The distance between them is 2. Okay, check. The second smallest and blah blah blah. Well, let's go through. The second smallest is 2. Then the second smallest is 3. So 2 3. Yeah, check. Then the third smallest is 3, and in both are 3. So let's say 3 3 3 3 3 3 1 2. Yeah. Okay. So third, yeah, it's 3 2. So 3 3 is 0. This difference is 0. Next number pair is 3 and 4. Distance 1. Fifth number something something. These are distance of 5 apart. Wait. Finally, the largest number in the left is 4, while the largest in the right is 9. 4 and 9. Okay, let's check 4 and 9. By the way, I heard there are people who finish this problem in 5 seconds. Like in 5 seconds. And the second problem in 4 seconds. So, Steve was looking into. So even if they are cheating, that's incredible speed. 9 seconds total solving this problem. So anyway, to find the total distance between the left list and the right list, add the distances between all the pairs you found. Okay, then then there's a sum. Okay, your actual left and right list contain many location IDs. What is the total distance? Okay, and it seems so. It's easy problem. Many people have said so. So there it is. Let's begin. By the way, this image is generated by Grok AI bot, and that's on x.com. And what is interesting about this AI generated image is that you ask Grok to draw you based on your tweets, based on your posts. So it's interesting. So it becomes a fashionable thing for people to do. Meme, so you just type in Grok. Where is it? Let me show you. Okay, a beautiful girl, amazing, beautiful, the center of humanity. This we have quite a lot. And so, I talked about the AI generation. So here is, so here is the image. Draw me based on my tweets, and Google came up with that. That's very interesting because, and by the way, it says ask Chat GPT to draw me. So apparently this is based on for my website, because I do have a photo of me using this iMac. So anyway, so that's interesting. Anyway, let's not talk about this. We did an episode about 3 months ago or 4 about AI image generation. So anyway, let's go back. Let's work on this problem. So, okay, so there is your input. Let's begin. So let's begin Wolfram language. We can finish this in an hour, in maybe 30 minutes actually. So Wolfram language, if you don't know, I'm using XR Wolfram mod that allows you to code Wolfram language in Emacs. And here is a Wolfram language. We're gonna use it too. This is a Wolfram notepad. It's free. You just search for XR Wolfram language tutorial. You'll find the link to download. It's officially free. Okay. Okay, so the input is, let's just say that, okay, so that's the input. So you have to pause it. Okay, so I haven't coded Wolfram language for a while. String split. Okay, now string split x input. Let's just name that. By default, it will input, I forgot, but let's just say x2 equal, x2 equals to that, and x3, by now, some of these people already finished the problem. Let's see what we got. Okay, so tab E to eval region. No, that's not the command. Tab Control H. What is the key? Example from eval region. Tab R. Okay, tab R. Let's see what is the result. Okay, so you got a list. So you got a flat list. So now you can just partition it. Okay, I'm 5% drunk. Not yet. So you got a list like 2 like that. So let's say x3 equals to what that key. Okay, equal. So partition. Okay, partition, not partial D. Okay, partition that will split the list into sublists of each n elements. Okay, so partition x2 by 2, so that you get pairs. Okay, eval the whole thing. Let's see. There it is. So how beautiful. This is Wolfram language is the most advanced high level, the highest level language. One Wolfram language equals to 10 to 1,000 Python lines of code. If you don't count the math functions, it's about one Wolfram language, one line is like 100 lines of Python. Okay, so there it is. So so now you just need to find the difference. Okay, now let me just do it. Transpose x3, then you just apply minus. Okay, subtract. What is the? I forgot what is the keyword for minus. I mean the full function name for the minus operator. I forgot. So let's ask Wolfram language. Okay, so you just say full form. Okay, full form, and what I want is x minus y. Okay, let's see what it tells you. Shift enter. Oh, okay, so it does, what does it do? It does, so yeah, so you see minus operation in formal mathematics is considered the inverse operation of addition. So minus became just the addition of a number. So minus a number means the additive inverse of that number. So in other words, when you have a number, say, let's say -3, in mathematics, you can consider it as a formal way. You consider that as a number whose additive inverse is 3. Okay, that's how you think about this. That is why. So anyway, so we transpose and we just want to find the difference. So what? So how do we? What is the? I want a single functional operation for subtract. I think it's just minus. Silly me. Yeah, there it is. Yeah, so I was silly. Anyway, let's just do minus. So you transpose this, then you apply minus. Okay, you can just do this. Okay, now you won't understand this, but let me just run it and you'll see, it will show the differences. Okay, now wait, okay, so actually you don't even transpose. Okay, so you can just apply minus. Let's map. Okay, so map minus. Okay, map the minus function to x3. So actually we don't want to map minus, so because let me just work it out. Okay, function x, what are we doing? So that will work. Okay, so let's just run it. Okay, no, map the function and the apply the minus code with 2 arguments. Oh, so actually not minus. Do we have subtract? No? Interesting. Let's look. Annoying. Yeah, oh, there is subtract. There it is. This is very old, I believe. Let's see, the function 1988, right? Yeah, subtract is what we want, not minus. Okay. Subtract. What? Subtract. Why don't I have the subtract symbol completion? Wait, maybe there's a bug in XOR Wolfram mod. Let's say 3.2. Okay, let's evaluate this line. What? Oh, subtract, not subtract. Subtract. Okay, idiot me. Yeah, there it is. Okay, so yeah. Evaluate that is 1. That's correct. Okay, So you just want that, evaluate the whole buffer. There it is. That gives you the difference. Now, except that these are, you see, it doesn't evaluate. The reason is that because those are actually strings. So we forgot to convert this string into a number. So you need to convert it to a number. So let's do that here, okay? So to expression, that's how you convert a string to a number, okay? Add that, okay? Now evaluate the whole thing. You see, fantastic. Now all you have to do is just say total. Add. Evaluate the whole buffer. -11. Oh, and you forgot to order them. You are supposed to order them, okay? So yeah, so if you want to order them, then let's do a transpose, okay? Then transpose, okay, transpose x3. Then you got a row of the columns. The second part is the right column. The first part is the left column, okay? Once you transposed, you just sort them. Actually, we can run it so you can see the intermediate result. No, okay, no is not correct. What? X3, run it. No is not correct. Why can't this be a string? Okay, it's problem. Okay, so you need to see exactly what is this output. So let's try it here. Shift enter, not control enter. Shift enter. So x2 postfix notation. Take the first. Okay, shift enter 3. Then but is that a string or number? So okay, so percentage sign means the last output, then postfix notation, then string q stand for question, enter, so it's a string. So so now you do to expression at x2. Now those are numbers. Now shift control L to copy it. These are numbers, that's right. Now if you do this shift control L, those are strings. You see, that's a difference. Okay, so to expression is right. So why is that? So when you to expression, that turns actually, that's why don't we put it here, okay? So now run it. Oh no, yeah, no, because because you got a semicolon there. So if you put x2 there, it's still no. So what the fuck is going on? String split to expression, so that's not supposed to be no, my friend. What? Oh, okay, yeah, that's right. Because of this, I got a null in Emacs Wolfram language because I got commented stuff there. Because otherwise, if I put this bottom, then it would not be null. That's right, you see? So actually our code is all correct. So now these are numbers. Now then you partition the numbers. Then you print x3. Let's print it here. Run it. So that's right. So that's right. You got group. Then you transpose it. And you transpose it and run it. You see, so 3, 4, 2, 1, 3, 3. That's the first column. Yeah. And now all you have to do is sort them. So you just say map sort, and the second argument is just gonna be that. So you got 1, 2, 3, 3, 3, 4. That's correct. Okay, now copy this so that we can see what's going on. So so after you sort them, you just make the difference. Okay, so then you just subtract. Okay, so you just apply there's an English issue. For some reason, I always thought of as subtract, okay, instead of subtract. Yeah, it should be subtract. So apply subtract to, so let's put this x4, okay. So subtract x4, then you just got a list of differences, okay. Then you just total. Hello guys, it's SIPA. Do you prefer Wolfram LAN or Emacs? Wolfram language, of course, by a magnitude. There's subtleties about that. Let me explain. So anyway, the solution to this toy problem is -11. Okay, let's check. Is 11. Okay, so how does it deal with the, let's see, how do they take the difference? Okay, so the smallest number in the first left is 1, then the smallest number, they only want, okay, so they want the absolute value of the distance. That is why they don't call it the difference, they just call it distance. Okay, tricky. You see, they don't want, why don't they want it negative? Because when you have a distance, the problem is slightly more complicated, because then you have to either find out which one is the bigger number, then you can minus, or you minus then take the absolute value. Okay, so we can do that. Okay, so apply subtract, then just absolute value. Okay, so absolute value is ABS. Okay, let's look up documentation. Why is it taking a long time? So turn on JavaScript. Apps gives the absolute value of real complex number. So that's right. So you give the apps, yeah, so that is it. Let's run it. 11, fantastic. Now we can combine this all to one single line, but let's not bother. Okay, so let's try the get my puzzle input. Okay, big numbers, big lotus. Put it there, and let's just override it. It's ugly, but nobody cares, because the advent of code, I noticed, it doesn't care if your solution is elegant or not. All it cares is that it just want a number. Okay, now so the number is that, so this problem is easy. We solved it. Fairly certain. Paste it. Do I double check? No. Submit. That's the right answer. Now you got a gold star. Continue to part 2. Okay, let's see. Okay, intermission. Let's talk about the Emacs Lisp versus Wolfram language and versus other languages, because language perving, computer language perving, is my expertise. This looks like a lambda expression. Which one? So I also solved using C++. Okay, so this guy, which guys are you on Discord? So anyway, this is an easy problem. Okay, so the question, Emacs Lisp versus Wolfram language. Okay, you see there's no comparison, and it's not fair, because Emacs Lisp is the language that you can only use in Emacs, and the area, it's actually so-called domain-specific language. So Emacs Lisp is not really a general-purpose language. What's a general-purpose language? Perl, Python, Ruby, JavaScript, C++, Golang, C#, F#, Haskell, and so on. Those are general purpose, okay, that you can use them to write just about anything. Emacs Lisp is not, because you can only run it in Emacs Lisp. I mean, in Emacs. You could run it as a script, but it's not feasible, okay? Because in any of those language I just mentioned, they need, in order to be industrial level, like not just one man's hobby, like a lot of people has, I'm going to write a compiler, that's, greatest language, I designed it, but that's one man's hobby. In order to be really truly useful, you need lots of libraries to access database, and they need to be efficient, okay, to access database, to access to interconnection with other systems, to talk to Unix pipes, to talk to or do HTTP, go through libraries for various protocols, so you need to have that. Then, and to be able to do them in an efficient way and massive scale, then you can call your language a general purpose language. So Perl, Python, Ruby, JavaScript, Java, C++, C#, they are general purpose. Golang and Rust. Okay. Now, of course, among them, there are still differences. For example, Python, Ruby, Perl, you don't really use them to write an operating system. Anyway, so that's getting into different things. But anyway, so they are general purpose. And in each of these language, you have very efficient libraries to access database, like billions, petas, something, exa numbers, massive scale. And so what about Emacs Lisp? Well, so you cannot do that, okay? So besides you need these libraries, you also, of course, you need a system to call them. You need namespace. You need namespace because your code is gonna be millions of lines. Emacs cannot do that, okay? I love Emacs, but among the Emacs fanatics, you got these people saying that, oh, I love Emacs. Emacs is best language, but actually, in reality, speaking of reality, Emacs compared to all these Python, Perl, Ruby, Emacs is shit. Okay, it's worth less than shit. You don't have namespace. You don't have a library system. You just, you do, but yeah, it's for like efficient, for editing, deleting text and things like that. Can Google use Emacs Lisp to access their petabyte database? No. But can Google do that with Java, JavaScript, C#, C++, or even Python? Yes. Okay. So Emacs is like, in comparison, is shit. You'll never hear people talk about things like this, like the way I talk, because most of the talking online is just shit. Cheers. But however, Emacs doesn't mean Emacs is like useless. Emacs Lisp, there's one thing Emacs Lisp does great, and no other language does it better, is text processing, because it is designed to do so. And the real reason why no other language, including Wolfram language, okay, Perl, Python, Ruby, including Perl is known as the best text processing language. No, not really. Or any of these language, including my favorite Wolfram language, when you compare to Emacs Lisp for doing the task of text processing, all the other become shit. Nothing beats Emacs. Why? Because Emacs Lisp got this buffer structure, which is like a glorified string. It's basically a data structure designed for manipulating text. Okay, so anyway, so if you are doing small scale text processing, nothing beats Emacs Lisp. Okay, which is what I'm doing, and which is what I'm doing for the past 15 years. By the way, recently I worked a lot on my packages and stuff. And if you like my stuff, just pay me, okay? Now, my Python mod is no good because it's just small. But anyway, so you go to my website, search for Xali Emacs Lisp packages. You'll find them. If you like it, pay me. I'm not going to peddle it now. So Emacs Lisp is a domain-specific language. So generally speaking, it cannot compare to any of these Perl, Python, Ruby, or C, C#, Java, C++. You cannot compare. Okay, no comparison at all. But I like it, for text. But for text processing, Emacs Lisp beats them all. Okay, now Wolfram language is the highest language of them all. Doesn't matter if it's Haskell or it's fancy Haskell or it's F# or it's Abda or it's like next generation of Haskell. Nothing comes even close. Not even close. Not even a little bit close in terms of expressibility. Like one line, like one line of Wolfram language Mathematica is like 10, 20, 100 lines of Haskell. Well, let me say it again. One line of Wolfram language is like 10 lines of Haskell, let's say. 20 lines of Python, 2 or 50 or 100, depends on whether you count mathematical functions. If you do count mathematical functions, such as a function returning derivatives, integrals, solve differential equations or difference equations, or or physics equations, there's like hundreds of them in Wolfram language. Each one of those functions is like equals to 100,000 lines of Python. Okay, so so if you count those, then one line of Wolfram language is equals to 100,000 lines of Python or JavaScript or whatever, or a billion lines of C. But normally programmers, the most vast majority of programming jobs, we don't do math. We don't need to solve differential equations. So let's say we don't count them. We just count about manipulating lists or strings. Okay, so for that, one line of Wolfram language is like 10 or 100 lines of Python. Okay, and similarly for Haskell, you can kind of just factor in. Okay, so that's about the differences between the these languages. And do I prefer Wolfram language or Emacs Lisp? Well, I would prefer Wolfram because it's just general, Emac list is just for text processing. Okay, so that's that. Shall we continue to problem 2? Okay, so let's do. So so far 40 minutes. Let's have some more drink. Let's see who else is watching. 5 people. Fantastic. Your analysis only confirmed what everyone feared. The 2 lists of location IDs are indeed very different. Or are they? The historians can agree on which group made the mistake or how to make it a common. You notice interesting, this idiotic drivel, the advent of code drivels. They just drivel and driveling. Lousy specification of the problem. Maybe the other number on location, handwriting. This time you need to figure out exactly how often each number from the left list appears in the right list. How often the left appears on the right. Okay. Calculate. So immediately that gets you think about, subsets, which set is larger and so on. Calculate a total similarity score by adding up each number in the left list after multiplying it by the number of times that number appears in the right list. Okay, it's counting problem. It's trivial. But they chalk it up to similarity score. Okay, and how is similarity score defined? Well, it's you count the, so adding up each number in the left list after multiplying it by the number of times that number appears in the right list. Okay, so you take the left column. For each number, you need to multiply it by multiplicity, and this multiplicity is defined by the number of times it appears on the right column. So 3, the first number 3 appears 3 times on the right, so you need to times 3. The number 4 appears 1 time on the right. Okay, the number 2 appears 0 times, so 2 times 0 is 0. Okay, number 1 appears 0 times, so 1 is also 0. Is that right? So let's see. First number is 3, so second number is 4, appears in the right list once. Okay, third number is 2, it does not appear, therefore 2 times 0 is 0. Okay, so we got it. So let's go back to the code. Yeah, so this time let's put the input, the toy input back. Okay, so that's a problem 1. Okay, so that's part 2. So part 2 cut. Okay, part 2, this is the input, and we need to let's just copy some of these. Copy. Okay, part 2. So 2 expression, correct. Then what you need to do, you need to partition it 3, 4. Okay, then you need to transpose. Okay, so let's see. Okay, so do you need to sort? This time you don't need to sort. Okay, so you just transpose. And meanwhile, let's make it into one line. Okay, so okay, so actually, so this is still pretty simple. Okay, run it. Yeah, we got that. Okay, so what is the next thing? 3, 4, 2, 1, 3. Wait, 3. Yeah, so okay, so you got 3 4 2 1, yeah. So you got these are columns, okay? So you got that, and for each one on the left you need to check how many times it occurs on the right, okay? So you this is so easy, okay? So but what's the best way? So first of all, how many times it happens? There's a built-in function in Wolfram language, okay? So okay, that function is count, I believe. Okay, let's check the documentation. Count, give the number of elements in list that match pattern. Give the number of elements in the list that match pattern, okay? Yeah, so list and pattern. So list and pattern, okay? So this is so easy. So let's first of all, we stop by map a function. Okay, what we want to map the function to? Map the function to x2. Okay. Okay, now, but the question is, what is the function? Now, the function is gonna be, okay, let's create some local variables. Okay, so module takes 2 arguments. The first argument is a list of local variables, okay? So column 2, let's say column 2 equals to x2, the second part, okay? Then column 1 is x2 first part, okay? That's kind of does that make sense? So you got a module, then you just want to map, okay? So then you map a function to column 1, okay? And the function, what does the function do? The function takes the, okay, so this is element in the column 1. This is one element. You take it, then you do count. Okay, so I mean you do x times count. Okay, then what is the count? The count is the pattern is x itself, and the list is column 2. Okay, that's what you do. So what you end up is yeah, x times that, then you just total. I believe that's the answer. Shall we do it? Yeah, let's just run it. 31. Let's, to be sure. Yeah, so you don't need, well, I mean, it's okay. 31. Yeah, I think I'm pretty sure. There it is, 31. There it is, 31. Okay, so now you just need the user input. So let's copy the giant big thing. Let's copy it again. Put this here. Run it. Okay, are you sure? Yeah. Paste. Submit. That's the right answer. Fantastic. So we are done. So does that make sense? You see, you know, so, you know, let me run this in Wolfram language so you can kind of see. Okay, so that's the huge input, you know, go up. That's the user input, 2 columns of numbers. Then the code is just 2 lines. You can make it 1 line, of course. Shift enter. Okay, and shift enter. So 23046,913. 23046,913. That's correct. Fantastic, beautiful. Anything else? Who else is watching? I think that's it. So tomorrow at noon, let's continue. Let's get this going. This is I'm sure it's a warm-up problem. The band of code, nasty warm-up problem. Okay. Nobody comments. That's it. I think that's it for today. Let's see, 50 minutes. Okay. Yeah, I think that's it. Let's see. If we put it back, syntax correct, show in browser, and there it is. Today's okay. It's a big numbers, yeah, but bye guys. Okay, pay me. Okay, pay me. You can buy my XR. Go to xrd.info. You can buy my Emacs tutorial and Emacs this tutorial. They are, I think, like 800 pages or 1,000 pages, and lots of stuff. The best tutorial for Emacs and Emacs Lisp on the web, and also in any printed books, in my opinion. Okay, so Emacs Lisp you can buy it. So I have done a huge amount of update every day. So busy. By the way, if you read my Emacs blog, every time you see this to do, that means I'm currently like reviewing and reworking on this page. For example, this page started in 2022. In fact, so this is about everything, the complete documentation about Emacs regular expression. So for Emacs regular expression, this page covers the syntax, like complete account of it. But this is only one out of 15 pages on Emacs regular expression. So you got introduction, you got Emacs commands using regular expression. Okay, that introduces you the commands that uses regular expression. Then this section is about regular expression itself. So you got Emacs regular expression, then how do you do that in Emacs Lisp, and the Emacs Lisp regular expression functions. You see, this is when you use Emacs Lisp to do programming, and how do you extract the captures and so on, and any or Unicode or escape Unicode and so on, and how do you test. So anyway, so in total I think there's like 900 or 1,000 Emacs pages in my Emacs tutorial. Let's go back. 970 plus plus you got miscellaneous articles, which is 240 miscellaneous articles, plus the complete Emacs and Emacs Lisp manual. Each one is like 900 pages. So you will get that if you pay me. So you can find the link, of course, by Emacs tutorial. Okay. Actually, I need to increase the price, but consider it's a donation. You are just donating, because this is I'm not selling that much, and I don't want to make it like a real commercial stuff, because when you do that, then it became lots of marketing and also the quality degrades, and you become, it's usually it's no good. I like the genuine hardcore stuff, and if you benefit, you like my stuff, you can buy it. That's what I'm saying. So there is that. Then of course JavaScript in depth. That's also, the one of the best JavaScript tutorial. You got. Anyway, I talked about this many times. Okay, so lots of programming tutorials. Just go to the bottom and pay me. Okay. Bye.